Hello, hello, hi. I hope I'm audible. I do think I'm audible. Just a second. Yes, so good evening. I hope you've all had a good day and you're ready to hack. Yeah, so just a second. I'm trying to connect to my pods. Okay, great. I hope I'm audible so someone can just confirm whether they can, whether you guys can clearly hear me. Can anyone confirm whether I am audible?
Yeah, you are.
Okay, okay. Thank you. Yes, so today's session will be part two of what we started doing last week. So, integrating ckERC-20 tokens to our dApp, to our different dApps. Yeah. So I'm just going to give like a brief overview of what we did during last week's session. Then, from this, then we'll get into now continuing the coding section from where we had left off from last week's session. So, as we had earlier stated, Chinky ERC20 tokens or ckERC20 tokens are ideally ICRC2 tokens, which are backed one to one with the underlying or with the corresponding ERC20 token on Ethereum. So we have a number of already implemented ERC20 tokens, which are Link and USDC, and they work the same way or similarly to ckETH and also CKBTC. That is, with this particular ckERC20 tokens are not reliant on any particular centralized bridges. So the, 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 the the it normally requires a number of smart contracts. So one particular helper smart contract on Ethereum and a number of canisters for it to be backed fully on chain on ICP. So how it works, as we had stated last week, is we normally use two particular canisters and one helper smart contract, which is live on Ethereum. So the first canister is the ckETH minter, which normally handles the ERC20 deposits and also withdrawal requests. And we had also mentioned that the reason that the ckETH minter is used is because these particular transfers, this withdrawal and deposits normally require the transaction fees to be paid in ETH. So that's the reason we're using the ckETH minter. The second canister is the Ledger Suite Orchestrator, also referred to as LSO, which is responsible for a number of ICRC ledger suites. So this particular ledger suite orchestrator normally links a particular ckERC20 token to a ledger canister ID, and which I will just demonstrate later on how it works. Then we have, of course, the helper smart contract on Ethereum. So the process of converting ERC20 tokens to ckERC20 tokens is normally simple. So the first thing the person will do is they'll call the approve function of the ERC20 smart contract, and they will allow that particular helper smart contract to interact with the ERC20 tokens on your particular MetaMask wallet. Then after that, of course, the user will call the deposit function on the helper smart contract. And in the arguments, they will specify the ERC20 smart contract that they're dealing with, the number of ERC20 tokens that they want to withdraw from their particular MetaMask wallet or their particular wallet or account, that is, and also the principal ID that will be credited for the minted ckERC-20 token. So the format of this particular principal ID is normally not in its principal ID format, but rather in its byte 32 address format. Then the helper of smart contract, of course, will transfer the set number of ERC-20 tokens to itself. Then if it's successful, it will emit an event to be consumed by the ckETH minter. So the ckETH minter periodically listens to the event that is emitted by the helper smart contract. Then every time it gets a new event, it means new tokens to that particular principal ID that was there as an argument. Yeah, and in the slides, you also like the user flow, which shows how it works. I want to go through it because I went through it during last week's session. Then converting ERC-20 tokens back to ckERC-20 tokens back to ERC-20 tokens is also simple. So the first thing is the user will have to call the ICRC2 approve function on the ckETH ledger to approve the CK minter to burn some of the user's ckETH tokens. So the reason we are doing this is because the ckETH tokens will be required for paying for the transaction fees. Then the second step is the user will call the ICRC2 approve function on the ledger of the given ckERC-20 token, and it will approve the minter to burn some of the user's ckERC-20 tokens. So the first step is approving this particular ckETH minter to burn ckETH tokens when the transaction is happening. Then the second one is now approving the ckETH minter to now withdraw the ckERC-20 tokens. Then the third step is now withdrawing the ckERC-20 tokens. So this particular procedure just follows the normal ERC-20 or the conventional ERC-20 procedure that is used in Ethereum in interacting with ERC-20 tokens on Ethereum, whereby the user has to approve that particular account or that particular smart contract to use the tokens in their particular accounts. Yeah. So if both operations succeed, it sends an Ethereum transactions that transfers the specified amount of tokens from the helper smart contract to the address that was provided. So also these are the use cases for ckERC-20. And yes, this is where we had left off. So how do you implement ckERC-20 in your dApp? Here's the link to the documentation. So once you click on it, it will send you to the documentation. But for me, I will open a new terminal on my machine. So I'll just close this. So just a second. Yes, so the first step is we have a particular helper toolkit that allows someone to easily mint ckERC-20 tokens to their particular principal ID. So I will send the link to this particular helper toolkit immediately after this session has ended. So it's called the CK tokens minter. So the main purpose of this particular toolkit is ideally it helps you mint different sets of CK tokens to your particular. This is specifically for developers who would like to now test the ckETH tokens to their particular dApps that they're building or their smart contracts. So instead of the developers having to write some repetitive code of minting the CK tokens to their particular IDs, this particular CK tokens tester allows developers to easily mint the the specified CK tokens to their particular principal IDs or canister IDs. So if I am a developer and I have my projects that I'd like to integrate either CK ETH or ckERC-20, any type of ckERC. Although the current supported ckERC-20 are ckUSDC, and also I think ckUSDT is also supported. I'm not so sure, but yeah, whether they'd like to integrate CK Sepolia ETH or CK ETH or ckUSDC or CK Sepolia USDC to their particular dApps. This particular toolkit allows them to mint the particular CK tokens to their dApp, and now once they've minted to their dApp, they can um, begin now creating functions that um, allows or interacts with this particular CK tokens in their dApp. So the first step, as you can see over here, how to mint. So this is CK Sepolia. If I'd like to mint now for this session, we are dealing with ckERC-20 tokens. So if I'd like to mint CK Sepolia USDC, I'll just click on that button and it will show me the section for minting CK Sepolia USDC. So as you can see over here below, it shows me the different steps. So the first step is to get the canister ID or the principal ID. The second step is I'll need to generate a byte32 address function from the principal ID. Then third step, of course, I'll connect my wallet. Then I will put the generated byte32 address in the deposit CK Sepolia USDC section, and I will click on deposit deposit that particular CK Sepolia USDC. So I do not have my canister ID yet. So what I'll do is just I'll come over here and I'll write dfx new CK Sepolia USDC session. So I'll just name it like that. Let me just do all small case. Then for me, I'm using Rust. So at this session, you're using Rust. I haven't implemented the front end a canister template, so it will just be doing purely the backend code. So I will come and open the project on using VS Code. As it opens, I will close my terminal. Then I will open my terminal on VS Code, and I will deploy the project locally so that I can get the particular canister ID of my smart contract or of my canister, that is. So I'll just do dfx deploy. So first of all, I'll have to start dfx. So I'll just do dfx start clean background. So my dfx is already running. The next step is I'll just do dfx deploy. So it will take some bit of time for it to compile the different packages that are there in the Rust canister, and also deploy it. So as it deploys it, just to give you like a brief overview on how the okay, just to mention, whenever you are sending or you're minting ckERC-20 tokens to your particular canister ID or your particular principal ID, if the canister ID is deployed locally, those ckERC-20 tokens will end up being locked in that particular canister ID. That is if you do like a dfx stop. This is because whenever you're generating the byte32 address of a particular canister ID, you tend to there's a high chance that um, the particular no, there's a high chance, but the particular byte 32 address that is generated is directly linked to, is generated from your canister ID that has been um, um, from your canister ID that has been deployed locally. So whenever you like redeploy your canister ID again locally, there's a high chance that the or your canister locally again, there's a high chance that the canister ID will change. So if it changes, it means ideally it means that the CK ERC20 tokens that you've sent to a particular canister, to the previous canister ID, have been lost. So the best way of navigating around this is normally just deploying your canister to the mainnet, or if you don't want to deploy a canister to the mainnet first, you can use small amounts of small amounts of that particular token. So if it's USDC, maybe like 1 USDC, 2 USDC, or even 0.1 USDC. So just avoiding sending large amounts of that particular ERC20 token to your canister ID if it is deployed locally, because ideally it will be locked in that particular canister and you won't be able to retrieve the money. Although if you're dealing with the test tokens, that is Sepolia USDC, Sepolia ETH, there is no need of worrying too much about sending a huge amount, because they are test tokens and they are what's the word, they are not, they are valueless. They don't have any particular value. Yeah. So it's compiling. It normally takes a bit of time for it to compile and redeploy. So as it compiles, we'll just go back to our minter, and I'll show you a few things. So once you've already minted the particular CK ERC20 token, so in this case the CK Sepolia USDC to your byte 32 address or to your principal ID, the next step is to verify that this transaction actually happened. So a quick way of doing it is just checking on this particular tab over here, and you'll see the previous transaction. So if I am to check whether I minted, so this is the backend canister. This is my byte 32 address of my backend canister ID, and I'm not sure which transaction over here I need to. So I'll just click on that transaction. What it's doing is utilizing the EVM RPC canister to make a call to the RPC JSON RPC method, or utilizing the JSON RPC method. So it's using the EVM RPC canister to make a call to Alchemy's API, which now fetches the transaction receipt via the transaction hash of that particular transaction. So I'll just click F and I'll see whether yes. So this particular transaction contains by my was the one that I sent the particular Sepolia USDC, oh, the particular CK Sepolia USDC to. So if I come over here, I can just see over here my byte 32 address is here, so I can verify that yes, the transaction happened, and I was able to mint the CK Sepolia USDC to my byte 32 address. So the main reason we're doing this is because whenever you've minted CK Sepolia USDC to your particular, or any CK token to a particular canister ID or principal ID, it normally takes some bit of time, if not hours, if not minutes, it takes hours for it to reflect to your canister ID, because I don't know why, but I tend to assume it's the CK ETH minter that's responsible for listening to logs from the helper smart contract is a bit slow, or it listens to logs in a batch transaction. That is, it takes it takes some bit of time for it to actually fetch like the logs from the um, from the from the helper smart contract. So since it takes a bit of time, it normally takes like a lot of time for it to reflect like the balance of your CK tokens once you've minted it. Yeah, so I can see my backend canister has deployed, and this is just the simple hello or greet name backend canister. So I'll just go to it. I'll just click on it. Go to it. Yeah, so what we want to do over here is just take the canister ID, of which one it's you can just copy this particular section over here, or I want to show you where exactly you can get it from so that you don't get confused. Yeah, so if you come over here in the top section, you can see your canister ID. So I'll just copy it over here, then come and paste it. So we can see from the different step, the second step is to generate the byte 32 address from the generate byte 32 address function. So I'll just come over here. I generate the byte 32 address, and I can see the byte 32 address has been generated successfully. I will copy it, but it seems the copy isn't working, so I'll just manually copy it. Then the next step is to connect my wallet via connect wallet button. So come over here, I will connect my wallet, and I can see this is my connected wallet, a wallet address. So the reason the pop-up didn't appear is because I had connected before, so it doesn't require me to confirm that connection again. And once I've connected my wallet, I will put the generated byte 32 address in the deposit CK Cipolla USDC section. So I'll just come over here and put my wallet address. Then I will enter the amount of CK Cipolla USDC I'd like to deposit. So since we're dealing with a locally deployed canister, will just deposit 0.1 Cipolla USDC. Then I will click on deposit Cipolla USDC. So the first thing that will happen is it will call the approve function in the ERC-20 token smart contract, so that I can approve the particular helper smart contract that's responsible for handling the CK USDC transactions, so that I can approve that particular helper smart contract to use my USDC that is in my particular MetaMask wallet, or my particular address of choice that I'm using. So I will come over here. So this is now the approve function. I will click next, and I will click on approve it to use it. So it's approving the helper smart contract to spend my Cipolla USDC. It normally takes some bit of time, but let's see whether it will work. Sometimes it tends to fail because of maybe network congestion, or the gas fees are too high, but most of the time it works. So it's taking a bit longer. Yes, so we can see the approval is successful, and now we can proceed with the deposit. Yeah, so it automatically proceeds with the deposit if the approval is successful. If the approval is not successful, maybe because of network issues, or something might have happened, gas fees are too high, of course it won't proceed with the deposit. If it does proceed with the deposit, high chance that the deposit function will fail because you haven't approved the helper smart contract to use your particular ERC-20 token. So in this case, only a USDC token. So I'll just click confirm. Yes, I will click confirm. So now it's minting CK Cipolla USDC to my particular principal ID. So to this particular principal ID that I had just copied. Yeah, so this function also takes time because of course, interacting with the Ethereum network. There's a high chance that there's a lot of traffic that's going on, and also the gas fees are too high. Maybe my gas fees are not that appealing to the nodes, so they prefer to take a transaction that has like a higher gas fee than mine. Yeah, but what it's doing currently is I think it has successfully, yes. So the deposit is successful, and now we can check, we can verify whether. So if you come and maybe we try to see my Sequoia USDC balance, we'll see that it's zero. But the main reason being, as I mentioned before, the balance doesn't automatically reflect immediately after we've made the transaction. It takes some bit of time because I'm not sure about this, but I tend to assume the CK ETH minter normally does the fetching of logs in batch. So like a batch transaction, it doesn't do it like every time, and it normally takes hours for it to like it's like a time frame of like hours. So like in every 2 hours it does the batch, in every 2 hours it does like fetching of the logs. So it takes some bit of time for the balance, the USDC balance, to reflect to my particular canister ID. But if I'd like to check whether the transaction was successful, I will utilize this particular section. So check previous transactions. I will just come and copy it. Then I will come to the latest transaction, which is the bottom one. Yes, the bottom one, and I will click on it. So it will fetch the transaction receipt of the transaction that just happened. Yeah, so it's taking some time because now it's fetching the receipt from the RPC URL. Then I'll just search for my particular canister ID that I had inputted, and yes, I can see it's over here. So the transaction is successful, and basically Sequoia USDC has been successfully minted to my canister ID. So I can go back over here, and now once it's minted, I can begin writing the specific functions of interacting with the Sequoia USDC to my particular smart contract, or to my particular canister. Yeah, so the first step is to add a certain dependency. So we'll now that we've minted the Sequoia USDC, we can now come to our um, our Rust canister code and now start writing some code. But before I write some code, in order to ensure that I compile everything successfully, I'll add a few things to my project directory. So the first thing I'll add is the bash shell script that's responsible for generating the DID files. So as you guys know, for Rust, whenever you're generating declarations or the DID files for Rust, you have to do it manually because because I don't know, because it's Rust. I'm not sure about the main reason, but you have to do it manually. So the best thing to do is normally to write this particular bash script file, which contains a candid extractor function that's responsible for extracting candid files from a particular Rust canister. So I'll just change this name to Sequoia. I just want to mess up the having typos, so I'll just paste it over there. Yes, so that's the DID file. Then the next step will be just a second. The next step will be adding now the candid extractor, which is a function we need to add to our backend, the lib.rs file. So the main Rust file that's responsible for now extracting the candid. I'll just add it. Yeah. So once I've done this, I can now start writing the code. So when I'm writing the code, the first there are few dependencies that I need to add that will enable me. They come with like pre-configured functions and also structs that um, reduce the time I'd spend in writing them. So the first package that I'm going to use is the B3 utils. So I'll just come and add the B3 utils to my cargo file, and it will automatically add the dependencies. I will remove this create function, and now I will write a function that's responsible for fetching the canister's USDC balance. So um, we are going to make like a few imports from the B3 utils dependencies. So I'll just try to use B3 utils, then ledger. And now for checking the balance, we're going to use two particular things. The first one is the icrc account, and the second one is the icrc1 struct. Yeah, so I'm going to import those particular structs. So I'll just do icrc icrc1 and also icrc account. Is that one? Yeah. Then now I'll write the function for checking the balance. But before I do that, I need to define the ledger canister ID that is responsible for storing the balance of the canister ID. So I need to define the canister ID of the ledger that's responsible for storing the balances, of which I do not need to go looking for it. So I'll just come to the template over here, and I can get the canister ID from this particular section. So this particular toolkit automatically fetches the canister ID, and it displays it for you over here. So you don't need to go like looking for it or searching for it. So I'll just come over here and I'll write const SBC canister ID, and it's a string, so that particular string. So now I will now write the function for fetching. I hope I'm still audible. Yes, I think I'm still audible. For fetching the balance of my CK, my balance of my CK USDC. So it's an asynchronous function. But first I need to it's a update call. So just do ICCDK update, then async function balance. So I'll just do like CK USDC balance underscore balance. Then I will add an argument for, because now I want to use like a principal ID or a canister ID that I'm sure has some CKUSDC, because the one that we just fetched to, or the one that we just minted to, will take some bit of time for it to reflect. Then I will create a sub account from using the icrca account. So I will create an account. Sorry, I'm supposed to, I shouldn't have pressed tab. Account, then new. Then we'll create account from the principal ID. Then our sub account is none. We're not using any particular sub account for this one. Then we'll now call the balance, the return balance function. So we will define the canister ID, then we'll call the balance of method. So from our account, then we will do an await, since it's an asynchronous function, then unwrap Yeah, so we'll save it. There are a few things I haven't imported: the principal, I haven't imported nuts, so I'll just quickly import them. Yes. Then I haven't my candid extractor. Okay, it works. So I will come to my terminal and just clear it, and I'll run the bash script file. I hope it runs. Sometimes it tends to fail because you haven't given permission denied. So if the permission is denied, I'll just write the following function to give it permission. Then I'll rerun. So what it's doing is generating candid candid from the new functions that I've just created. So that's why I'm using the did.sh file. Then it's redeploying our newly or our pre-configured um, backend Rust code here, so that we can now fetch the balance of USDC from a particular canister ID. So it takes a bit of time for it to compile and also deploy it. So we'll just wait. Don't worry, I'll send a link to the documentation immediately after this. That will be way to help you like follow up. It will be way easier, because you'll be reading along with the documentation. So as it fetches, or as it compiles, I want to show you. So if you'd like to confirm the different canister IDs of the different CK tokens that exist, the best way of confirming whether the canister ID is the correct one is by coming here to the Internet Computer dashboard. Then it's taking time to fetch the details. Then you come here to the chain fusion section. Then now you can see you have CKBTC, ckETH, so it contains access to the different CK tokens that exist. But since we are dealing with CK Sepolia USDC, I can just come to the CK Sepolia USDC token, then I can see the different canister IDs that are responsible for the transactions that are related to CK Sepolia USDC. Sure. Yes. So as it continues to deploy, so we can see this is the orchestrator. So this is the ledger orchestrator that I had mentioned a while back, which contains if I come to the yes, I can see it has deployed it, but I'll just come to the orchestrator later. Let me just show you. This is the minter. So this is the ckETH minter. This is the index canister, and we have the ledger canister. So I can clearly see that this particular canister ID is the one that I have over here. Yeah, this one, the one that I have over here. So we're using the correct canister ID to fetch the balances of our ckETH token. So once it has successfully deployed, I'll come. Let me just reload this. Then as it reloads, I'm going to check to get a canister ID that I'm sure has some CK Sepolia ETH in it. Then I will check the balance of CK Sepolia, not ETH but USDC, CK Sepolia USDC. Or let me just say CK USDC, so that I don't confuse myself. So I'll come. I'll just input the address over there. Then I'll call it. Yes, I'm getting an internal server error. So let me just check where the error is coming from. Just a second. Yes, so the error is because apparently I have to deploy this thing to the mainnet for it to work. Oh my god! So let me just quickly see whether I can do that. Yeah, because ideally it's trying to interact with the USDC canister ID, of which is deployed to the mainnet, but then I can't I cannot directly interact with it because my my canister is on the it's deployed locally. So I'll just see whether I can quickly deploy this to the mainnet. Let me check my ICP tokens balance. Yeah, so okay, I have like 0.2 ICP. I really hope that will be enough. I really hope. So I will write the second command for topping up cycles to my particular. But let me try deploying it. Not sure whether it will work, but I highly doubt it will work. Yeah, because I don't have enough cycles. So I will come and I will top up cycles to this particular canister ID very quickly. So it's topping up the cycles. Yeah, so I'm not sure whether these cycles will be enough, but let's just try out and see whether it will work. So I'll create. I want to create a new canister ID to the mainnet. I'll just put the canister name over there. Then I want to create it with these particular cycles that we just top up canister ID with. So it just happened. Yes, so let's see whether it will create it successfully. Yeah, so there are not enough cycles, so I have to like do it again. So let me do it with 0.1 cycles instead. Okay, let's now try creating it again. So since we are doing another session inside this session, converting ICP tokens to cycles and deploying a canister to the main, which we already did that session a while back. But it's okay, sometimes it's good for recapping. It is to remind yourself. So we've already topped it up, so let's try deploying it to the mainnet to see whether it will work. Yeah, we just hope it will work. So installing the canisters, so installing the code for the canister. Yes, and it has successfully deployed it. So yeah, you can see you can easily deploy a canister to the mainnet in a matter of minutes, if not seconds here, just if you know the right commands. But the good thing, we already did such a session a while back, and you can just go and recap on it to see how we can easily deploy a canister to the mainnet using by converting ICP tokens to cycles using a terminal. So let us load the canister, and we call the function. Yeah, so I'll come and get my my principal ID, the one that I'm sure has some ckUSDC, because as I had mentioned before, we cannot fetch the balance of our currently minted ckUSDC because the ckETH minter normally takes time to fetch logs, so it normally takes like a few hours. So let's just fingers crossed that the function works. Yes, and you can see we have a balance of around, if you convert this into the 6 decimal, if you convert it to now the normal decimal, it's around 1 point something Cipolla USDC, or rather USDC. So just something to note, apparently we have to deploy our canister to the mainnet for it to fetch our balances, because it's interacting with the USDC canister ID, a ledger canister which is deployed on the mainnet. So if we are working with it locally, there's a high chance that it won't work. So we'll go to the next function, which is now let's assume that we'd like to convert our ckUSDC tokens back to USDC. So there are different steps to follow. The first one is we will need to import a few structs from the B3 utils package that we had just installed a while back. So this particular the B3 utils library, and those structs will need to import the ICRC2 approve. So the approve arguments, and also approve results. So just to mention, as you're aware, we have the ckUSDC. It's an ICRC2 token. So the reason we're using ICRC1 format over here is because ICRC2 token is just an extension of the ICRC1 token, meaning an ICRC2 token still contains functions that are present in the ICRC1 token. Then the reason we are using the ICRC2 structs over here is because ideally our ckUSDC token is an ICRC2 ledger canister, or it's an ICRC2 token. So yes, of course, the structs that we'll use are the ICRC2 token structs. Then the next thing that we need to do is we need to define or create variables for our ckETH ledger canister. So I'll just come over here, then canister ID. So yeah, I'll just call this ledger just to differentiate. And also I see we're out of time, but we're almost done. The next thing that we'll do is of course ckETH minter canister ID. In future, I hope the toolkit will be able to display the different ledger canister ID and minter canister ID. But if you can't get it from the minter, you can get it over here. So you'll just come over here. We can say the minter is this one. So we'll just copy it from the, what just happened? I clicked, sorry, I clicked the minter. Yeah, so we'll just get it over here, copy it, and I clicked it again, but it's okay. I will input it, whether it's supposed to be a string, but this is the minter, this is not the ledger, this is the minter canister ID. Then I will come and now get the ledger canister ID. I'll just go back. Ledger canister ID, which is I will come to chain fusion, then this probably is. Then I will copy it over here, which is this one. Yeah, but all these things have been clearly stated in the documentation, which I will share it by tomorrow. We'll just copy it, then okay. The method is seeming impossible to use. Yeah, come and insert it over here. Yeah, so now let's create function that will allow us to withdraw Sepolia, that to convert the ckUSDC tokens to back to USDC. So the first thing that we need to do is for the withdrawal to be successful, the first step is we need to call the icrc2 function from the ckETH ledger. So this is the main reason we define the ckETH ledger canister ID over here. So because of time, I'll just go and copy the function and paste it over here. Yeah, and we can see I will change this to canister ID, then I will change this to ledger canister ID. Yes, correctly. So the first thing to create a sub account from the principal. Then the second thing is since we're using the ckETH minter as a spender, we will create we'll get the minter principal, which is this one, and we'll also we will now create an ICRC account from the this particular minter principal that we've just gotten from this particular minter canister ID. Then after that, we will now create the arguments that are responsible that will be to be called using this ICRC2 approve function. So of course the arguments contain a from sub account, which is this particular our specific principal ID that's supposed to now convert the particular ckUSDC to USDC. Then spender, which is the ckETH minter canister ID. The amount, of which is the amount of tokens that you're going to spend. All these fields, we just put them to none because they're not really necessary. Then we will come and use the intercall. I haven't imported it, so let me just import it very fast. Yes, we'll use the intercall function from B3 utils. So the intercall function is just a function that allows you to do intercanister calls. Yeah, so you don't have to create like a whole new function for doing intercanister calls. You can just do it directly using this B3 utils library. Then of course we need to specify whether we are using cycles or we are not using cycles. So I'll just import the call cycles function from the B3 utils API, of which it has the different fields. So we have no pay whenever we are not using any cycles. We have pay whenever we're using cycles that using cycles to call that particular function. Then sub account, we need to import it from B3 utils too. I hadn't imported it yet. Yes, you can see this is the sub account. So yeah, so this is the function for approving ckETH burning. So as I had mentioned before, we need to approve ckETH burning since withdrawal of ckUSDC to USDC needs some certain fees that are paid in Ethereum, or not in Ethereum, in ETH or in Ether. Yeah, so we need to approve the banning of ckETH, and the version of Ether or of ETH we're using in ICP is ckETH. Yeah. So the next step is now approving um, uh, ckUSDC now for the purpose of now withdrawal. So we will call the ICRC2 approve function from the USDC ledger that will approve the CK the minter, which this particular minter, to now ban the USDC tokens. So the main purpose we are banning the ckUSDC tokens is because we are converting them from ckUSDC to USDC. So those tokens don't need to be in the ecosystem again. They're being banned completely. Of which, for you guys that have done tokenomics, you understand the whole meaning of minting and banning tokens. So that will be the CK intercanister ID, USDC ledger. This is supposed to be this one. Yes, then you save it, and so just to it follows the same structure as the approve ckETH banning. So of course creates a sub account from the principal, creates an ICRC account from the minter principal, that's the CK minter. Then the arguments are the same. Then it calls, we're using an intercall a function from the B3 utils library to enable us to do the intercanister calls. Then now the final function of which it's supposed to allow us to withdraw now to directly now withdraw the the ERC20 the CK Cipolla USDC to our accounts. So in order for us to write the function, we need a few structs or a few structs. The first one is we need a withdraw ERC20 argument, and also a withdraw ERC20 struct result struct. So we'll just import them. But now they're using SAD, but I'll just import that library. I'll install that library later. The next step is now to write the function. So here's the function. I'm getting an error, but it's okay. So I'll just come and change this to CK canister ID. Then I'll save it. I'll also change this to CK canister ID. Then I'll save it. I can see we have a few errors. The first one is we have a missing field over here, which is the ckERC-20 ledger ID. So the reason we are getting the missing field is because it's a typo over here. So just save it. See whether we have another error over here. The main reason we're getting the error is because we haven't installed this particular SAD library. So we'll just go to we'll go and take it and install it right away. So let me just fetch it a second. So if you'd like to get this particular libraries easily, there's a particular crates website that allows people to directly install the different libraries to their canisters. Yeah, I'm seeing we're way past time, but this is the last bit of it. Let's just get the SAD library and install it and deploy our code. So just search for SAD. SAD. come and copy it, then I will add it to my terminal, to my dependencies file. Then yes, we can see the errors have gone, and now our canister is ready to be deployed. Yeah, so I'll just come over here, clear my terminal. Wait, something just happened. Okay, that's just a compiler error, and I will deploy my canister. Yeah. So as it deploys, this is the last bit of it. Then we'll wind up the session. Um, the withdrawal functionality won't work because our canister doesn't have any Sepolia, any CK USDC yet. Because as I had mentioned before, the USDC that we had minted to the canister isn't. I forgot to do something over here. So if I reload this, you can. Let me just show you guys. If I reload this, you can see that we won't have any updated functions in our on our canister. It's taking a lot of time to reload. Yeah, mostly because we didn't run the bash script file. So I'll just run bit.sh and okay, let me just do this and redeploy it again. And redeploy it again so that I can have the newly created functions appear on the Kali UI. So as I was mentioning, it won't work mostly because when we were fetching or when we were minting the Sepolia, the USDC to a particular, or rather when we were minting CK USDC to our canister ID, that it takes a bit of time for the USDC to reflect on our canister ID. So for now, the functions won't work only until the minted Sepolia, the minted ckUSDC reflect on our particular canister ID. Then the other thing is, now in order for us to successfully perform the transaction, we need to ensure that our canister ID also contains, or rather our canister also contains some ckETH, because as we had mentioned before, we need ckETH for the canister to successfully pay for the transaction fees. But if I come over here and copy the particular canister ID and I come and check whether it has ckETH, I will see that my canister ID has 0 ckETH. So let's just see. Yeah, so you can see ckETH balance is 0. So even if I try to run this particular function with an argument of 1, it will fail because it will return insufficient balance. Let's just wait and see. Yeah, you can see we have an area of which is our balance is 0 because we don't have ckETH to perform the transaction. And that is it. So ideally, that's how you integrate ckERC-20 tokens to your particular canister or to your dApp. And now I assume all of you know how to now call these particular functions to your front end or on your front end canister. Yeah, so we'll ensure that the recording has been shared by tomorrow, and also we will share the respective documentation and also a link to this particular toolkit that allows you to directly mint the respective CK token to your canister ID. Yeah, so I don't know whether there are any questions. We have any questions? Okay, nice. I'll just assume that we have no questions. So for now, I'll reshare the slides again, and also I'll reshare the links here again. Otherwise, thank you so much for turning up for the session, and have a good night.
Hello, hello, yeah.
Yes, yes. You have a question, cool kid.
No, no, I'm good.
Oh, okay, okay, okay. Have a good
Thanks
night,
for
guys.
yes.
Oh yeah, you're welcome.